Hi everyone, we're working on the Practice HiSet Test Fpt7 and we're on question number 11. This one is not going to take your students very long at all, so this is one of the ones where they can save a lot of time. Question 11 says, it takes one bag of chocolate chips to make 72 cookies. How many bags does it take to make 18 dozen cookies? What your students need to understand first of all is how many cookies is in a dozen, which would be 12. So we're going to go to our calculator and we're going to make 18 dozen cookies, which means we're going to make 216 cookies. Now we're going to take that amount and divide it by 72, and we're going to need 3 bags of chocolate chips to make that many cookies. Could it be any faster than that? That one was pretty quick. So that one is going to let them bank a little bit of time, especially when they're dealing with other problems that are a little bit more difficult. Now, question number 12 is a probability question. It says each time a coin is flipped, it has a 50% chance of landing on heads and a 50% chance of landing on tails. The coin will be flipped 3 times. What is the probability it will land on tails all 3 times? And then the answers are written as fractions. This is going to throw the students off a bit because we have percentages in the question and then we have fractions in the answer. So I'm going to go to the whiteboard, and what we're going to do is we are going to flip the coin 3 times. If it's got a 50% chance, that means it's 1/2. So it's got a 50% chance the first time, a 50% chance the second time, and a 50% chance the third time. We are going to multiply these because that's how you work probability problems. Multiplication of fractions, multiply straight across the top, we get a 1. Multiply straight across the bottom, 2 times 2 is 4, 4 times 2 is 8. So you've got a 1/8 chance, which is A, that this is going to land on tails all 3 times. So again, another really quick question. I've been recording for almost 3 minutes doing those 2 questions, so those were very, very fast. Now the next one is not asking them to actually solve a problem. Instead, it's asking them to write out an equation. And what I generally do with these questions is I tell them, cover up the answers. We're not interested in the answers right now. We're interested in the question itself. Because what happens is whenever they see the answers, they're automatically going to try to pick one that goes along with what they're reading. We don't want to do that. Instead, what we're wanting to do is we're wanting to look at the information in the question and use that to solve the problem. So it says, hold on one second. It says an electronics store offers to finance the purchase of any single item with 0 interest for 1 year with a down payment of $60. The rest of the purchase price will be split evenly into 4 quarterly payments. Which of the following equations represents the relationship between the amount A dollars of each quarterly payment and the purchase price S dollars of an item under this offer? So what your students are going to need to do is they're going to need to, hold on one second. What they're going to need to do with this is they're going to need to write this out in a way that makes sense and then come back and compare it to what they actually see on the options that they have. Okay, so let me get this put in real quickly. I should have done this before I started. Okay, so this is our question. It says, the electronics store offers to finance the purchase of any single item with 0 interest for 1 year with a down payment of $60. The rest of the purchase price will be split evenly into 4 quarterly payments. Which of the following equations represents the relationship between the amount A dollars of each quarterly payment and the purchase price S dollars of an item under this offer? So we're going to start off with S dollars, okay? The S dollars is the total amount that they have paid for this particular item. And we don't know what the amount was, but we do know that they put a down payment of $60 down on the item. Okay, this is an S, not a 5. I'm trying to make it look more S-like. Okay, this is an S, not a 5. Okay, so we do know that they put a down payment of $60 and that came out of the original purchase price. Now what's left over here is going to be divided into 4 equal payments. Okay, so 4 quarterly payments over 1 year's time. They don't need to understand necessarily what quarterly means. They do need to understand that they're going to be 4 payments. Okay, so what is the relationship between the amount of each quarterly payment? Each quarterly payment would take the original price, subtract $60 from it, and divide it by 4. So that's going to be the amount of the quarterly payments. And if you go back to the original problem, you'll see that A equals S minus 60 divided by 4. The reason I like to do the problems this way without looking at the answers first is because always students are going to try to match an answer with a question without ever really figuring it out. Instead, they're just going to say, well, we're doing 4 payments, so we need to divide something by 4, and we're taking 60 away. So chances are they would choose C instead of choosing A. So that's the reason I like to tell them with this type of problem that what I want them to do is I want them to cover up the answers and figure out how they would work the problem, and then they can go back and look at the answers. So our next problem is a little bit more complicated because it's the average rate of the change of a function from x equals 3 to x equals 6. So when we're dealing with the change of a function, what they've done for us here is instead of using the f of x like what we saw earlier, they're using the g of x. And when we see that, sometimes it's very confusing to students, but it means essentially the same thing. And what they've done is they've taken this equation and they want to know the average rate of change if the function goes from this to this. This is a lot of complicated language to say what happens if we replace the x with a 3 and what happens if we replace the x with a 6. So we're going to do those two things and figure out what's going to happen. So first of all, we're going to replace it with the 3. Okay, 3 squared is 3 times 3, which is 9, minus 1 gives us 8. So hold on to that number. And now we're going to replace it with the 6. Six squared is 36 because 6 times 6 is 36, minus 1 gives us a 35. Okay, so this is the change between the two of them. But what they're wanting to know is the average rate of change. So they're wanting to know something slightly different from what we have right here. So what we're going to do to get the rate of change is we're going to take the larger of the two numbers, which is 35, and we're going to subtract the 8 from it, because that's going to tell us the change that's taking place. Then we're also going to take the 6 and the 3 and do some subtraction there. This is what's going to tell us the rate of change. So again, I don't like relying on my own math, because this is where I mess up 90% of the time on my test. So I'm going to take 35 and subtract 8, and I'm going to get a 27 right here. 6 minus 3 is 3. Then when I divide this out, what I'm going to see is that 27 divided by 3 is 9. So the average rate of change between these two in this particular function is going to be 9. All the students need to understand with this is that when they're seeing that g of x, that means that they're substituting. They're telling us what x is, so we can substitute the 3 here and we can substitute the 6 here. This gives us the biggest portion and the smallest portion. And since we're looking at rate of change, that means that we're going to see what the distance or difference is between those two. So that means that we're going to be doing some subtraction in there. And that's the reason why we're able to set the problem up this way, and that's the reason why we're able to solve it like this, is because we're moving between that rate of change with both of those different values for x.